Next, we are going to see is about isotopes, isobars, and isotones. Okay. So first, what is meant by isotopes is isotopes have the element which has a same number of protons but different number of neutrons. So as we know, X is at A. Yes, so same number of protons is this will be same, okay, and different number of neutrons. Neutrons is if you minus this, that gives you a number of neutrons, is it not? And so, in other words, we can also say it as isotopes are the atoms having the same atomic number. So atomic number is Z, but different mass number. Mass number is what? A. Okay, so it will have same Z but different A. And example is given as 1 H11, H12 and H13. So see in this values are all same and these values are all different. Okay, so we can say that it has same atomic and different mass numbers. Okay, then next is the number of isotopes is very abundant. And so we can say that carbon has a 4 main isotopes. So here also if you see, these are all the isotopes because these numbers are all same. Okay, C611, C612, C613 and C614. Okay, so it has the same number of atomic number. Okay, same atomic number. Okay, but in nature C612 is approximately 98.9%. C612 we are having in abundance, and C613 it is 1.1% and C614 it is 0.01%. And when you see with this C611, that does not occur naturally and it produced only in the reactions in the laboratory. Okay, and the chemical properties are determined only by the electrons. The isotopes of any element have same electronic structure and same chemical properties. Okay, so isotopes will have same electronic structure and also same chemical properties. Okay, and so the isotopes are placed in the same location in the periodic table. So periodic table enna pannirpaanga, all the isotopes are placed in the same location. Okay, clear? The next is isobars. So what is the isobars is they are the atoms of different elements having same mass number. It is not the same element. Okay, we are having the different element. Okay, so different element we can consider as X, Y, Z and all that. Okay, it has same mass number but different atomic number. So it will have the same mass number but different atomic number. So this atomic number will be different. Okay, so when you see the example here, see here. Okay, so in this all, this atomic number is mass number is same and atomic numbers are different. Okay, so it has the same number 40. Yes, so these are all the isobars. Okay, clear with what are isobars? Then the next one is isotones. So isotones have same number of neutrons. So what is meant by neutrons is if you minus this and this, the value will be same. So see here, we are given with the example as B5 12 and C6 13. Okay, so minus this and minus this. Okay, so 12 minus 5, the answer is what? 7. And same way 13 minus 6, the answer is what? Again 7, is it not? So it has a same number of neutrons. Okay, then next we are going to see is about the atomic and nuclear masses. Yes, mass of the nuclei is very small when it is expressed in SI units. So when you are writing the value of nuclei in SI units, it is very small. Therefore, it is convenient to express it in other terms, that is called as a atomic mass unit. Okay, so we are going to express as atomic mass unit. So what is meant by atomic mass unit is it is defined as 1 by 12 the mass of isotope of carbon C612. Okay, so 1 by 12th of C612, if you take with this value, that gives your atomic mass unit. Okay, and so that we are writing as atomic mass unit is denoted by 1 U, and that is equal to 1 by 12th of this. So we are writing mass of C612 divided by 12. So if you write the mass of this carbon, it is 1.9926 into 10 power minus 26. This divided by 12, so we get 1.660 into 10 power minus 27 kg. Okay, so this gives your atomic mass unit. Okay, then next we have the size and density of the nucleus. So when you consider the alpha particle scattering experiments, many other measurements using the different methods has been carried out on the nuclei of various atoms. Then we have also found that the nuclei is approximately spherical in shape. ஸோ இதில் என்ன சொல்லிட்டாங்க அப்படின்னா நியூக்ளியை வந்து ஸ்பெரிக்கல் ஷேப்பில் தான் இருக்குது அப்படின்னு சொல்லிட்டாங்க. அண்ட் த ரேடியஸ் ஆஃப் த நியூக்ளியஸ் ஃபார் இஸ் இட் கிரேட்டர் தேன் 10. ஓகே, ஸோ எதுக்கெலாம் வந்து அட்டாமிக் நம்பர் கிரேட்டர் தேன் 10 இருக்கோ அதுக்கு வந்து ரேடியஸ் வந்து வேல்யூ என்ன இருக்கும் அப்படின்னா r is given by r is equal to r0 into a power 1/3, where a denotes what? A denotes the mass number. Okay, A is a mass number, and this R0 is a constant. That value is given by 1.2 Fermi. F denotes Fermi. Okay, so what is the Fermi? Its value is 1 into 10 power 15. Okay, so instead of Fermi we can write as 10 power 15. So this value becomes 1.2 into 10 power minus 15. Okay, so this is the value of R0. So if you know the value of Z, we can just substitute here and find the value of R. Okay, next is mass defect and binding energy. Okay, so in mass defect we have to know mainly with this formula. Okay, so that is given by Isotome, which is equal to del m which is equal to Z into mp plus n into mn minus m. Okay, so here Z denotes the atomic number, mp is a mass of proton, n denotes the neutron number, mn is the mass of the neutron, minus m, that is the total mass. So when you have to find the binding energy in this, binding energy is given by del m into c square. We already know the value of del m here, is it not? So this value into c square. Okay, so this value into c square, that gives the value of the binding energy. Okay, so next is we are going to find what is the binding energy curve. The average binding energy per nucleon is the energy required to change the state from a single nucleon or the particular nucleus. So what is meant by energy, that is the binding energy, is it is the energy required to separate a single nucleon. So இங்க இருக்கிற ஒரு proton and neutron ரெண்டு combine இருக்கு இல்லையா, that is called as what? Nucleon. Okay, so அந்த nucleon separate பண்றதுக்கு how much energy is being given. Okay, so energy given to separate a single nucleon from a particular nucleus. So ஒரு nucleusல இருந்து ஒரு nucleon எடுக்கிறதுக்கு how much energy is required. Okay, so that is said to be the average binding energy. And now we are going to see the graph between the A and the binding energy. Okay, yes, this is a graph between the A, which is the mass number, and this side we have the binding energy. So when you see the difference in this binding energy as well as the mass number, we can just see that the value of binding energy rises as the mass number increases. So mass number increase ஆக நம்மளுக்கு binding energy என்ன ஆயிட்டு இருக்கு, increase ஆயிட்டே போகுது. Okay, until it reaches a maximum of 8.8. so நம்மளுக்கு இந்த வேல்யூல 8.8 எங்க வருதோ அதுவரை என்ன ஆகுது, இந்த binding energy வந்து increase ஆயிட்டே போகுது. Okay, for A is equal to 56. At that time here when you see the value of A, that is equal to what? 56, and that corresponds to iron, and then it decreases slowly. So இதுக்கு மேல போச்சுனா என்ன ஆகுது, it started decreasing. Okay, next is the average binding energy per nucleon is about 8.5. so average binding energy இங்க இருந்து இங்க binding energy பார்த்தோம் அப்படினா the value is what? 8.5 MeV. and the 8.5 MeV எதுல இருந்து எதுக்கு வரையும் அப்படினு பாத்தீங்கன்னா between 40 and 120. Okay, so 40 and 120 குள்ள அதோட average energy எப்படி இருக்கு, 8.5 இருக்கு. So these elements are more stable and not radioactive. Okay, so இந்த elements 40 and 120 குள்ள இருக்கிற elements எப்படி இருக்கு ரொம்ப ஸ்டேபிளாவும் இருக்கு and they are not radioactive radioactiveவும் இல்ல அது. Okay, clear? So first point is 8.8 MeV அது வந்து corresponds to என்னது A is equal to 56. Okay, and the next is the average binding energy, that is 8.5, that corresponds between 40 and 120. So that are more stable and they are also not radioactive. Then the next one is for higher mass numbers. So if you go to the higher mass numbers, the curve reduces slowly. So curve enagudhu slower reduce agudhu. And for uranium is about 7.6. So 7.6 MeV la da enagudhu started reducing. So these elements how they are unstable and also radioactive. So இந்த elements வந்து unstable ஆவும் இருக்கு radioactive ஆவும் இருக்கு. Yes, clear with this 3 points. Okay, first 8.8 la A is equal to 56. Next 8.5, that is between 40 and 120. So they are stable and not radioactive. Next is 7.6, that is for uranium, they are unstable and radioactive. Okay, next is if two light nuclei with a less than 28. So இப்போ A வந்து less than 28 ல பார்த்தோம் அப்படின்னா combine with the nucleus which is A less than 56. So A less than 28 ல இருந்து A less than 56 வரையும் பார்த்தோம் அப்படின்னா the binding energy per nucleon is more for the final nucleus than the initial nuclei. So initial nuclei விட final nuclei ஓட binding energy எப்படி இருக்கு, it is large அப்படின்னு சொல்லியிருக்காங்க. Thus if light elements combine to form a heavier nuclei, a large amount of energy is released. So அதனால light elements எல்லாம் combine பண்ணி நம்மளுக்கு வந்து பெரிய nucleus form ஆச்சுன்னா we'll have some large amount of energy, and that has a principle of nuclear fusion, and this nuclear fusion is used in the hydrogen bomb. Yes, clear? So between 28 and 56 all the elements are very light, and if all the light elements are combined together that forms a heavier one, that is called as a nuclear fusion, and that principle is used in hydrogen bomb. Next is if a nucleus of heavy element, அதே மாதிரி ஒரு heavy element வந்து என்ன பண்றோம்னா it has been split so that it has two or more lighter nuclei அப்படினும்போது அங்கேயும் என்ன ஆகுது, it releases energy, and that is also large amount of energy, and this principle is used in what, atom bombs. Okay, and this is called as what, fission. Okay, and this is called as fusion, this is called as fission. Yes, clear? Next we are going to see is about nuclear force. So what is meant by a nuclear force is the force which is between the proton and the neutron inside the nucleus. So if you consider the nucleus, it consists of what, proton and neutron. So the force between this, that is called as a nuclear force. So when you see here from electrostatic we have learned that the like charges repel each other, and in the nucleus protons and neutrons are separated by a very few distance. Okay, so protonium நியூட்ரானையும் என்ன பண்ணியிருக்கோம், ஒரு ஸ்மால் டிஸ்டன்ஸ் செப்பரேட் பண்ணி வச்சுருக்கோம். the distance is what, 10 power minus 15 meter. Okay, and they must exert on each other a very strong repulsive force. So இது ரெண்டுத்துக்கும் நடுவில் என்ன இருக்கணும், ஒரு strong repulsive force இருக்கும். For example, if you take the repulsive force between the proton separated by distance, we get, and we know already the formula for f is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square, is it not? So instead of 1 by 4 pi epsilon naught we are writing as k, and q1 and q2, instead of q1 as well as q2 we are going to substitute the value as q. Okay, so q into q, that becomes as q square divided by r square. Substitute the value of k here, which is 9 into 10 power 9. Then q value is the charge of the electron, which is 1.6 into 10 power minus 19. Then distance is what, it is separated by 10 power minus 15. Okay, so when you just solve this, we'll get the value as 230 Newton. Okay, so from this we can also find the acceleration. So what is the formula for force from Newton's second law is F is equal to m into a. From this, if you need the value of a alone, bringing m value down, so we get a is equal to f divided by m. So just now we found out the value of f, and m here we are going to write the mass of the proton. Okay, so when you divide, we'll get the value as 1.4 into 10 power 29. Okay, and here we have the properties of the nuclear force. The first one is strong nuclear force is very short range. So when you see the nuclear force, it is a short range force. It acts only up to a few Fermi. Fermi is what? 10 power minus 15. So only up to certain distance this nuclear force can exert, but inside the nucleus the repulsive Coulomb force or attractive gravitational force are weaker than the strong nuclear force. Okay, so inside the nucleus நம்ம பார்க்கும்போது நம்ம ஏற்கனவே பார்த்த கூலும் ஃபோர்ஸ் அண்ட் ஆல்ரெடி பார்த்த கிராவிடேஷனல் ஃபோர்ஸ் அதெல்லாமே என்னவா இருக்கு? வீக்கர் ஃபோர்ஸாக இருக்கு when you compare with the nuclear force. So inside the nuclear force is the strongest. Okay, similarly the gravitational force between the neutrons is much weaker than the strong nuclear force between the neutrons, and so nuclear force is said to be the strongest. So nuclear force எல்லா ஃபோர்ஸ்லயும் நம்மளுக்கு வந்து strongest force இருக்கு அப்படின்னு சொல்லியிருக்காங்க. Okay, then second point is the strong nuclear force is attractive and it acts with the equal strength between the proton proton, proton neutron and neutron neutron. Okay, ஸோ இந்த ஸ்ட்ராங் நியூக்ளியர் ஃபோர்ஸ் எப்போவுமே எப்படி இருக்குது? அட்ராக்டிவாக இருக்குது. அது எதுக்கு நடுவில் ஆக்ட் ஆகுதுன்னு பார்த்தீங்கன்னா ப்ரோட்டான் ப்ரோட்டான், ப்ரோட்டான் நியூட்ரான் அண்ட் நியூட்ரான் ப்ரோட்டான்குள்ளே தான் ஆக்ட் ஆகுது. ஓகே, பிகாஸ் இட் இஸ் ஆல்வேஸ் இன்சைட் த நியூக்ளியஸ். தென் நெக்ஸ்ட் பாயிண்ட் இஸ் த ஸ்ட்ராங் நியூக்ளியர் ஃபோர்ஸ் டஸ் நாட் ஆக்ட் ஆன் எலக்ட்ரான். எப்போவுமே ஸ்ட்ராங் நியூக்ளியர் ஃபோர்ஸ் எதுக்கும் நடுவில் ப்ரோட்டான் அண்ட் நியூட்ரானுக்கு நடுவில் மட்டும்தான், எலக்ட்ரான் மேலே அது வந்து ஆக்ட் ஆகாது. ஸோ இட் டஸ் நாட் ஆல்டர் த கெமிக்கல் ப்ராப்பர்ட்டி. ஸோ கெமிக்கல் ப்ராப்பர்ட்டி எதுவுமே ஆல்டர் ஆகாது. Okay, so that is the third point.